Here we have the limit as x tends to 4 of the quantity x plus square root of x divided by the quantity 3x plus 1. The first thing I would do is try to substitute in 4 for every value of x. If we do that, we get 4 plus root 4 over 3 times 4 plus 1. 4 plus 2 is 6. 12 plus 1 is 13. We get a real number. Now this function does not involve anything exotic like a piecewise defined function or a greatest integer function. Nothing like that. The most exotic thing we have is the square root of x, but that doesn't cause any problems until you get into the negative values of x, or at least close to the negative values of x, which we have not done. Here we have the limit as x tends to 0 of the quantity x squared minus 5x minus 6 divided by the quantity x squared minus 36. And I believe that's supposed to be the limit as x tends to 6. So again, the first thing I would do is try to substitute in 6. Well, if we substitute in 6, we're going to get 36 minus 30 minus 6. That's 0. And in the denominator, we're going to get 36 minus 36. That's also 0. We get 0 over 0. Remember, that's an indeterminate form, which is to say, from this, we cannot tell what the answer is or if the limit even exists. So we need to do something more. Well, in this case, I think what I would do is factor. The numerator factors into x minus 6 and x plus 1. The denominator factors into x minus 6 and x plus 6. This simplifies, and so we're left with the limit as x tends to 6 of x plus 1 over x plus 6, which is 7 over 12, I believe. Here we have the limit as x tends to 25 of x minus 5 root x over 3x minus 75. First thing I would do is try to substitute in 25 and see what I get. Well, you're going to get 25 minus 5 times 5, which is 0, over 75 minus 75, which is also 0. If you get 0 over 0, that's your hint to try something else. Well, it doesn't really factor very much. It does have the square root in it, and very often when you have a square root in the numerator, what you want to do is try rationalizing the numerator. So in this case, what we do is we look at this expression with the root. We've got x minus 5 times square root of x. We've got two different terms. What we need to do is multiply this entire function by the conjugate of the numerator, the part that has the square root in it. So since the square root is in the numerator, we're going to look at the conjugate of the numerator. Now, how do you find the conjugate of the numerator? Well, if you've got a plus the square root of b, the conjugate would be a minus the square root of b. If you've got a minus the square root of b, the conjugate would be a plus the square root of b. So what we need to do is multiply by 1 in the form of x plus 5 root x over x plus 5 root x. So I'm going to FOIL this together. X times x is x squared. X times 5 root x is 5x times root x. Minus 5x times x is minus 5x root x. And then minus 5 root x times 5 root x is going to be minus 25x. Square root of x times square root of x is x, as long as x is non-negative. And in the bottom, I think I'm just going to leave that like it is. The reason I'm going to do that is we're going to try to get something to cancel, and before we can do that, everything needs to be factored. And the denominator was not causing us any trouble, so I think I'm going to leave it as it was, or as it is. All right, so now let's combine the like terms. In the numerator, we're going to have x squared minus 25x. And in the denominator, we still have 3x plus 5 times x plus 5 root x. Now, if we try to substitute in the 25, I think we're still going to get 0 over 0. But notice that you have a common factor of x up here. Let's try to factor that out. You know, I've just noticed that I've done something a little bit strange here. That should be 3x minus 75. I'll rewrite it correctly in this next stage. You could probably almost hear the gears grinding in my brain as I noticed that something was not quite right. And it was the fact that I had this copied down incorrectly. Well, now if you'll notice, you've got a common factor of 3 here that we can take out. Those go away. And we're left with the limit as x tends to 25 of x over 3 times x plus 5 times square root of x. And if we substitute in 25 for x, we get 25 over 3 times 25 plus 5 times the square root of 25. And that's 25 over 3 times, I think that's 3 times 50. And we can get some cancellation there, and I think that reduces to 1 over 6.